Good morning, everyone.
Good morning.
How are you today?
Fine, thank you. And you?
Fine, thank you. Okay, well, I hope you're ready because we're going to learn something really interesting today. But first, I will take attendance. Marta Lucía San Román.
Present.
Jimena Díaz.
Here.
Valeria Ayala.
Here.
Today, we will talk about a mathematician, a Frenchman. His name is Blaise Pascal. Anybody recognize him?
I know. Pascal is a unit, isn't it?
Well, yes, but Blaise Pascal did much more than that. He was a philosopher and a physicist. Please look him up on your cell phones. Tell me what was his most popular creation.
But how much time do we have?
We have still enough time.
Okay. Me.
You found it?
Yes. It's a calculator. No, it was a Pascal triangle.
Exactly. Well done.
But Miss,
Yes?
how is somebody who created some unit and the calculator related to our class?
That's the story I'm about to tell. In 1623, a great mathematician, philosopher, and physicist was born in Clermont, France. After his mother died, his father took him to Paris. At a young age, he was homeschooled by his father, Etienne, who used to be a great mathematician, and at first he didn't want Blaise to study math. Later on, he realized that his son was a brilliant boy and gave him his first book. In the 1640s, he invented the PASCAL line, an early version of a calculator.
Yes, it actually took me 3 years and 50 prototypes to do it.
The difference between the calculator that we use nowadays and the Pascaline calculator is that the Pascaline calculator used to be in a rectangle metal form and it only worked for adding, subtracting. It was so basic it didn't work for specific operations, differently than the actual calculators which exist, like the grapher and the scientific, which help us do everything in an easier way.
Oh, that's so interesting.
In 1654, Blaise Pascal created the probability theory with Pierre de Fermat.
Long time. We haven't even given the theory a name.
I have been thinking about it and I like the probability theory.
Yeah, I like it too.
And that's exactly where our class is related to Blaise Pascal. Today we will talk about the probability density functions. Every continuous random variable, x, has a probability density function, f of x. These probability functions count with the following conditions. This is for all the x.
What are density probability functions used for?
Probability density functions are used to determine what is the probability that a continuous random variable exists between two given values. For example, a and b. This probability is given by the following function. I'm going to write it down on the board.
Okay, Miss, but can you do an example, please?
Of course, here it goes. So first, we need to prove if this function is actually a probability density function. To do so, we'll need to show the following procedure. As you can see, the limits were altered. This is due to the fact that these are the only ranges where the function is not equal to 0. In this the integral can be reduced down to the only interval where the function is not equal to 0.
Miss, so we changed the intervals?
Is that possible?
Yes, you need to find the intervals that will not give you 0. Now we will find the probability. We have our specific limits, so this would be the equation and procedure. To obtain the percentage, we multiply our answers times 10, times 100. So it's going to be 0.08658 times 100, and that will give us 8.658%. So the probability of x being 1 and 4 is 8.658%. Everybody understood?
Yes. Not really.
Don't worry, it's easy. I can help you.
Thank you.
Okay, now classwork. And it's to hand in.
Ah.